square root of 30. What about the next one? I can remove a 2. Now, can I put all this together? No. There is not one of those terms that are like the others. That is your final answer. See, now we're back at addition and subtraction. To be able to add and subtract, they have to be alike. But they're not. So we have to be able to take our brains and flip-flop between when you're multiplying and when you're adding. And what's the difference? What can you do? That's your answer. Okay?
What was that? FOIL?
That was FOIL with radicals. All right. God, I'm here already? Okay. Let's do another FOIL problem with radicals. Let's say we've got let's say we've got this right here. I want you to do FOIL. Apply the multiplication lesson that we just learned. Simplify all your stuff and then add together what you can. Okay. First times first. First times first, you have a whole number 2, and under the radical, you have 2 more 2's. Outside terms multiplied together are these here. We've got negative 4 times 2 is 8 times the square root of 2. Inside terms multiplied together, we have plus 3 square roots of 2. Last times last was negative 12. What can you do with this first term? You can pull out a 2, which gives you 4. All right, I'm just going to rewrite it real quick. Those 2 inside terms are what? They're alike. You can put them together. My first and my last terms are alike. They're both whole numbers. I can put them together. So 4 minus 12 is a negative 8. And negative 8 square roots of 2 plus 3 square roots of 2 is negative 5 square roots of 2. Using FOIL to be able to put together these radical expressions. All right? And then we go back to how do we simplify? How do we add? What can we put together? Lots of things being used here. All right. Golly. I forgot we were on Pep Riley's schedule. Let's see how much we got left. A lot. All right, well, let's start with this. How do you do fractions? Same way with multiplication. You divide the outside stuff, you divide the inside stuff, okay? But the radicals have to be the same. They both have to be cubed root or square root or whatever. In this case, if you notice, the radical hat encompasses the entire fraction, right? So that means that it's the cubed root of 27 divided by the cubed root of 24. Since the whole thing is under that grouping symbol, what does the order of operations say to do first? Parentheses are groups, right? So if we can simplify this fraction, then we need to do that first. Can you simplify 27 over 4?
Yes.
To what?
3, 7, 6, 3, 8, 9 over 8.
9 over 8. Okay? I need to go back. I'm sorry. I gotta go back to this. When you have fractions, in order for this to be simplified correctly, you cannot have a radical in the denominator of a fraction. So we've got to figure out a way to change this fraction without actually changing the value.
Square the whole thing.
I don't square the whole thing. How do you take 1/2 and make it have a denominator of, say, 10, but it still represents 1/2? If I multiply the denominator by 5 to turn it into 10, then I have to do the same thing to the numerator, right? And now that's 5/10, which still represents a half. Well, when you're dealing with radicals in the denominator, if I want to remove that 2, I'd have to have 2 of them under there, right? So I would multiply by the square root of 2, because what happens in the denominator now? What's the square root of 2 times itself?
Square root
2. But if I'm going to do that in the denominator, I also have to do it in the numerator so that I don't change the value of the fraction. So in the numerator, I have the square root of 2, and in the denominator, I simply have the whole number.
So it can't be in the
2.
denominator.
You cannot have a radical in the denominator. Okay? All right. Now, pay special attention. You cannot reduce this 2 with this 2. Can someone tell me why?
They're not radicals.
One's a square root of 2, which is actually 1 point something, something, something. And the other one is the whole number 2, which means like 2 peas in a pod. Okay? All right. If this was the fraction and we wanted to remove 10 from the denominator, the square root of 10 from the denominator, what would we multiply both parts by?
Square root.
The square root of 10. Whatever you multiply the denominator by, you do the same thing to the numerator. The reason, what does this value equal? 1. Okay, you're really multiplying by 1. You're not changing it. All right, so in the numerator, we have 3 square roots of 10, and in the denominator, we have 10. Okay? Then we just need to make sure that our whole numbers can't be reduced, which they can't. 3 and 10 are both whole numbers, but they don't reduce. And these two 10s cannot cancel because one's a radical while the other one is a whole number. All right? Now going back to this problem. Oh, that worked out. Sorry. Since they are both under a cubed root now, this is the same thing as this. In the denominator, can you take the cubed root of 8? Can you find the cubed root of 8? Yes. So since you can, you don't have to now multiply by the same thing. That is reducible just as it is. What is the cubed root of 8?
2.
Can you find a cubed root of 9? So this would be your answer. Okay?
You get 9.
I reduced 27 fourths by 3. 3 goes into 27 9 times, and 3 goes into 24 8 times. Okay? All right, the bell is about to ring, and I did not get as far as I wanted to get. So, oh man. 27 through 33. And 39 through 40. All. Adjust your homework assignment. Sorry.